This video will explain what a thermochemical equation is. What you see in front of you here is a thermochemical equation, and the most sort of distinguishing feature is the fact that it gives you the ratio of the reactants and how many products are formed. But this is the important part here. The enthalpy for this reaction is negative 92 kilojoules per mole. So this negative symbol here is what tells us this is an exothermic reaction. This is a reaction that would give out heat. Here is another example. This is the combustion of methane. So you've got 1 mole of methane reacts with 2 moles of oxygen, and it produces carbon dioxide and water. This is also an exothermic reaction because it's got a negative value here, which indicates that it's exothermic, and that tells us that it gives out heat. A note, all combustion reactions are exothermic. You won't ever find a combustion reaction that absorbs heat energy. They always release heat energy. How do you know it's a combustion reaction? One of the reactants here is oxygen. That's how you know you've got a combustion equation. Now, it is relative, so what I want to do now is just show you, if we double the proportions, so instead of having 1 methane, 2 methanes will now need to react with 4 oxygens, so I've doubled the oxygens. You will produce 2 lots of carbon dioxide and 4 lots of water. Now, it is likewise for the energy. If 1 mole of methane produces 890 kilojoules, then it goes logically that 2 moles of methane would be twice the amount of energy released. I guess you could think of it like chocolate bars. If you eat 1 chocolate bar, you're getting, let's say, 250 calories. If you eat 2 chocolate bars, you get 500 calories. It's the same idea with this. It's a law of multiple proportions. Here we go. That is the same equation, which I don't want. So let's go to this one here. Here we have 2 moles of hydrogen reacting with 1 mole of oxygen, and it's making water. And it releases 570 kilojoules per mole. So the question is, how much energy would you release if you only burnt 1 mole of hydrogen? So we're going to be halving the amount of hydrogen, which means you need half the amount of oxygen, and it goes without saying that you would logically get half the amount of water produced, and that results in only half the energy. Okay, so you not only use up half the fuel, which is hydrogen in this instance, but you produce half the amount of water and half the amount of energy. So this is what I refer to as the law of proportions. Let's see if you can do this one on your own. If you've got nitrogen gas reacting with oxygen gas, it produces, now actually this is an endothermic reaction. They're not common, these ones, but notice now the symbol is a plus, which indicates that it's an endothermic reaction. So this one absorbs 33.8 kilojoules. So if you only have half a mole of nitrogen, question is, how much energy would you produce? Now, you can be excused if you've got your calculator or reach for your calculator. And if you say 16.9 kilojoules, you're right, it would be half the amount of energy. I'm going to stop here, and you can stop the video, and I would like you to go through page 112 in your SciPad and have a go at these mole ratios, and I'll catch you in the next video.